Hello, I am Rajesh Kumar. Today we will study the first in chemistry first chapter, that is some basic concept of chemistry. In this chapter we will discuss about the some basic terms to be used whenever we will go for the study of chemistry. So that's why this is the first chapter, that's called some basic concept of chemistry. We will start in this chapter. First we will take an introduction of science. Science is considered as a systematic knowledge to describe and understand the nature. It is subdivided in different disciplines, which mainly includes chemistry, physics, biology, geology, etc. Now the chemistry is that it deals with the study of composition, structure and properties of matter and the change which the matter undergoes under different conditions. Chemistry is called the science of atoms and molecules also, because it deals with the different atoms and molecules. Now about the importance of chemistry. At the present, chemistry plays a very important role in our daily life. It has helped us to meet our requirements for a better life, such as food, good health, comforts, etc. Some important applications of chemistry are: first application is that contribution to better health and sanitation. Life-saving drugs like cisplatin and Taxol have been found to be very effective for cancer therapy. AZT, azithromycin, used for helping AIDS victims. These compounds are obtained from animals and plants or by synthetic methods. Discovery of anesthetics have made surgical operations more and more successful. Analgesics have been reduced pain of different types. Antibiotics like chloromycin, streptomycin have helped to cure disease like typhoid and tuberculosis. Now the second application, saving the environment also. Refrigerants like CFCs, chlorofluorocarbons, which destroyed the ozone layer, have been replaced by environment-friendly chemicals. Supply of food. The use of preservatives has helped to preserve the food products like jam, butter, etc. And another application in the transportation and communications. Almost all means of transport, including automobiles, aeroplanes, helicopter, railways, use petrol or diesel or coal, which are all chemical products. Application in industries. Chemistry has played an important role towards development and growth of number of industries. Example: cement, glass, leather, dye, sugar, plastic, etc. Now the next is about matter. Anything which has mass and occupy space is called matter. Everything around us composed of matter. Example: book, water, air, living beings, etc. Matter can exist in three physical states. These are solid, liquid and gas. These three states are interconvertible by changing the conditions of temperature and pressure. First is solid. In solid, particles are held very close to each other in an orderly manner. Solids have definite volume and shape. Example: metal, book, etc. About liquids. In liquids, particles are close to each other, but they can move around. Liquid have definite volume but do not definite shape. They take the shape of container in which they are placed. Example: water, etc. Gaseous. In gases, particles are far apart as compared to solid and liquids. Gases have neither definite volume or not definite shape. They completely occupy the container in which they are placed. Classification of matter. Matter can be classified in two categories. First is physical classification and second is chemical classification. In physical classification, matter is divided in three categories as solid, liquid and gas. In chemical classification, matter is divided in two categories: pure substance and mixture. Pure substance. a material containing only one substance is called pure substance. They have fixed composition. Example: copper, silver, gold, water, glucose, etc. These are the example of pure substance. Pure substance further classified into two types. First is element, an element that contain only one kind of particles. These particles may be atoms or molecules. Example: sodium, copper, etc. Compounds. Compounds are pure substance containing more than one kind of elements or atoms in a fixed proportion. The properties of compounds are completely different from those of its constituents elements. Example: CO2, SO2, NaOH, etc. Compounds may be divided into the following two categories. First is organic compounds. Compounds containing carbon and few other elements like oxygen, nitrogen, sulfur, etc. are called organic compounds. Inorganic compounds, these compounds containing any two or more elements. These are usually obtained from mineral and rocks. Mixture. A mixture contains two or more substances present in it in any ratio which are called its component. Mixture may be homogeneous or heterogeneous. Homogeneous mixture. In a homogeneous mixture, the components mix with each other and its composition is uniform throughout. A homogeneous mixture consists only one phase. Example: air is a homogeneous mixture of number of gases are nitrogen, carbon dioxide, ozone, etc. Liquid homogeneous mixture like petrol, kerosene oil, diesel, etc. Heterogeneous mixture. A mixture is said to be heterogeneous if its composition is not uniform throughout. A heterogeneous mixture consists of two or more distinct phases. The components of heterogeneous mixture are visible with naked eyes. Example: mixture of salt and sugar, sulfur and common salts, smoke, a mixture of carbon particles and air. Air is also a heterogeneous mixture if dust particles are taken in consideration. We will do the example of heterogeneous mixture like these are three components. If we will consider only one component, that is sugar, second component, that is salt, and third one component, that is soil. Independent, individual, each of three are each of it is example of homogeneous mixture because it has contained only one type of chemical properties or one type of phase. If we will mix these three components with each other like this, we will take some amount of soil also, second one some amount of sugar and some amount of that is NaCl salt, and we will mix with it each other. Then we are crossing the limits of homogeneous mixture and we are going to enter in the range of heterogeneous mixture because we are going to mix the different components. It is creating to the formation of heterogeneous mixture. Properties of matter and their measurement. Properties of matter can be classified as physical properties and chemical properties. Physical properties, there is no change in chemical composition, while in chemical properties there is a change in chemical composition. The International System of Units, that's SI. The International System of Units was established by the 11th General Conference on Weights and Measure. The SI system has 7 base units as unit of length is meter, unit of mass is kilogram, that's kg, unit of time is second, unit of electric current is ampere, unit of thermodynamic temperature is Kelvin, unit of amount of substance is mole, unit of luminous intensity is candela. Mass and weight. Mass of a substance is the amount of matter present in it, while weight is the force exerted by the gravity of an object. Mass of a substance is constant, whereas its weight may vary from one place to another due to the change in gravity. The mass of a substance can be determined very accurately in the laboratory by using an analytical balance or electronic balance. Volume. Volume has the unit of length cube. So, in SI system, volume has unit of meter cube. But in chemistry laboratories, smaller volumes are used. Hence, volume is often denoted in centimeter cube or decimeter units. A common unit liter is used for measure of volume of liquids, as 1 liter is equal to 1000 milliliter and 1000 centimeter cube is equal to 1 decimeter cube. In chemistry laboratory, volumes is also measured by burette, pipette, measuring cylinder, etc. Density. Density of a substance is its amount of mass per unit volume. Density can be given as D is equal to mass upon volume. In SI, unit of mass is kg and SI unit of volume is meter cube. So, unit of density will be kg meter per meter cube. Temperature. Temperature is the degree of hotness or coldness. There are 3 common scales to measure the temperature as degree Celsius, degree Fahrenheit and Kelvin. The thermometer with Celsius scales are calibrated from 0 degree to 100 degree Celsius. These are 2 freezing points and boiling points of water respectively. The Fahrenheit scale is represented between 32 Fahrenheit to 212 Fahrenheit. The relationship between degree Celsius and Fahrenheit can be given as degree of Fahrenheit is equal to 9/5 degree Celsius plus 32. The Kelvin scale is related to Celsius scale as follow: K is equal to degree Celsius plus 273.15. Now notice the temperature in negative values in Celsius scale is possible, but in Kelvin scale negative temperature is not possible, as the different kinds of thermometers are there. So, in next lecture we will study about uncertainty in measurement, significant figures, dimensional analysis and laws of chemical combinations. Thank you.